In this video, we're going to take a look at energy efficiency. So by the end of this video, you will be able to calculate the electrical energy used in kilowatt hours and determine its associated cost. You'll be able to calculate the percent efficiency of any electrical device. And you'll also be able to determine key information from an EnerGuide label. So let's just jump right into it. Before we get into some calculations, we first need to define what electrical energy consumption is. It is really just the amount of electrical energy used. And typically it's measured in a unit called kilowatt hours, or kWh for short. Now, a kilowatt is 1,000 watts, and a watt is 1 joule per second. So a joule is a typical unit used for energy, and because we use many joules of energy per second, we tend to look at energy consumption in this kilowatt hours because then it makes the numbers a little bit more manageable to deal with. So first up, we're going to take a look at calculating electrical energy consumption. So the equation we want to use here is that the energy used in kilowatt hours is equal to the power in kilowatts times the time used in hours. So for example, if we had a microwave that used 0.8 kilowatts and we used it for half an hour, then we can figure out the energy by taking the 0.8 kilowatts and taking the half an hour and putting it into hours. So that's 0.5 hours. And so if we did that, we would get an energy of 0.4 kilowatt hours. So the most important thing to remember here is that your time does need to be in hours. So if it's in minutes, you do need to convert that into an hours before you do this calculation. Now, if we know how much energy is used in kilowatt hours, and we know the cost per kilowatt hour, we can figure out the total cost for using that device. So going back to our microwave, if we know, let's say we want to find the cost, and we know that we've used 0.4 kilowatt hours for that half an hour of use, and it costs 0.08 cents or $0.08, which is 8 cents per kilowatt hour, then our cost for using this is $0.032, which is the same as saying 3.2 cents. Now that might not seem like a lot, but this adds up over time. And so all of our electrical devices can be quite costly as we use them in our homes. Another useful term or a useful calculation for us to do is to look at the percent efficiency of an electrical device. This is defined as the ratio of the useful energy that comes out of the device to the total energy that went in. So when energy comes into a device, it will use some of that energy in order to produce useful energy to come out, but then quite a bit of it can get wasted. And so knowing the percent efficiency will help us to decide what sort of device we want to use, because the more efficient it is, the better it's going to do in terms of using our energy and turning it into usable output energy. So this is usually calculated as a percentage. And if we take a look at light bulbs, for example, a typical incandescent light bulb is really inefficient, so only about 10%, which is why they are no longer being used or being sold, because they are super inefficient with our energy. If you take a CFL bulb, it's a bit better, 70%, and then an LED bulb, which is what you see in the stores now, is 95%. So that means 95% of the energy coming in is being turned into light energy going out. Now, in order to determine the percent efficiency, we can use this equation here, where the percent efficiency is equal to the useful energy output over the energy input, and then multiplied by 100% to give us a percentage. Looking at an example then, suppose we had a light bulb that uses 780 joules of input energy to produce 31 joules of light energy. What is its percent efficiency? The first thing we need to do is pull out the information we need. Now, because the 780 says input, our input energy is 780 joules. And then 31 joules of light energy means that that is our output energy. And so that's 31 joules. So to find the efficiency, we're going to take the output, which is 31 joules, over our input, which is 780 joules, multiply that by 100 to put it in a percent, and that gives us a percent efficiency of only 4.0%. So this is a pretty inefficient light bulb here. One thing you do need to keep an eye out for is to make sure that both the input and the output energy are in the same units. If not, you may have to do some conversions to make sure that they are the same. Finally, the last thing we want to take a look in this video is EnerGuide labels. Now, if you've ever gone and looked at any sort of appliance or electrical device that's being sold in stores, most of them have these EnerGuide labels on them now. And they tell you some really key information about how much energy an appliance or device is going to use. The first thing it tells you is in really big numbers here, this 300 kilowatt hours tells you how much energy on average it's going to consume. Sometimes it'll say per year, sometimes it'll say per month. This is an average use, and so gives you some sort of idea on how much energy it will consume. Underneath that, it also shows you a comparison of energy consumption to different brands and models of the same sort of device. And so you can see here, it's on the lower end of the scale, where most of these appliances or devices here go from 285 to 484 kilowatt hours. So this one's pretty efficient because it's on the lower end of the scale. And that's really nice because that gives you that comparison to take a look. Finally, the last thing, and you don't see this on all of them, but this Energy Star label is a great quick way to know if a device is very efficient or not. Only the most efficient devices are given the Energy Star label. So if you see it, you know that your device is going to be very energy efficient. That's it for this video. Let's move on to our next task.